Hey guys, this is the 11.4 screencast, at least for the front page. I'm going to do the back page in class, but this is previously 6.5, so ignore this. That should say 11.4. All right, so I think you guys can handle the warm-up 1 through 4. 5 and 6, I'll ignore. You can check the key that's on the calendar for the answers for 1 through 4. Today we're going to do a refresher on complex numbers. So this first part I wrote here, the standard form for a complex number is a plus bi, where a is the real part and b is the imaginary part, or the coefficient for the imaginary part. So that's just a refresher, and then we're going to learn how to graph these today and write them in a few different forms. So we have a complex plane here. Instead of an x-axis, this is your a-axis. That's your also known as your real axis. And then here's your b-axis, which is your imaginary axis. So if I want to take a plus bi, I can actually write that as a comma b. And that's how I turn a standard form complex number into an ordered pair. So for example, if I have 3 plus 4i, I can write that as an ordered pair, 3 comma 4. And I would go 1, 2, 3 on the a-axis, 4 on the b-axis, and that's how I can graph that. Absolute value of a complex number. So if you think about absolute value of any number, not a complex number, it's the distance away from 0. So when we talk about absolute value of a complex number, when we're graphing it, it's the distance away from the origin. So absolute value, distance from 0, 0. And if you think about that, a straight line from the origin to any point is really like the hypotenuse of a right triangle, right? Because we take a rectangular path to get there, straight left and right for my a value, straight up and down for the b value, and then connecting straight from the origin from that point would represent basically a hypotenuse. So the absolute value of a plus bi, I can use the same symbols. We also tend to call that r, kind of like radius. So you'll hear me, or you'll see me probably just write it as find r. It's the absolute value. It's the distance from 0, 0. It's going to equal the square root of a squared plus b squared. And what you're looking at is essentially the Pythagorean theorem, only we've taken the square root of both sides to solve for the length of r. So let's do an example. If I had this 3 plus 4i, and if I drew the absolute value, it would be that distance there. Well, I know this is 3 units. I know that's 4 units because my ordered pair 3 comma 4. So the absolute value of 3 plus 4i would equal square root of 3 squared plus 4 squared. And we know, because that's a 3, 4, 5 triangle, that would just equal 5. All right, so that would be the absolute value of 3 plus 4i. All right, let's talk trig form. Trigonometric's kind of a mouthful, so I usually just say trig form. Trig form of a complex number. I'm going to write this as, let's see, I need r and I need theta. We just went over how to solve for r. Let me talk about how to solve for theta. Theta is going to be equal to inverse tangent of b over a. Think of that as like y over x. That's really what we're talking about. So going back to like our unit circle stuff, that's going to find you a reference angle, and you need to adjust it for what quadrant you're in. So if you're not in the first quadrant, you need to use reference angle to figure out your direction angle, just like we did in the unit circle chapter. So I'll do a few examples of that. But let's see, once you have r and theta, the trig form for a plus bi is going to be r times cosine of theta plus I times sine of theta. And because theta is always going to be the same, because we're talking about the same angle, we can use a shorthand notation. I'm not inventing a new trig function here, but we can write this as r times cis of theta. We say cis of theta, and that literally means the c represents cosine, the I and s represents plus I times sine of theta. So this is your trig form. It's also known as the cis notation. So you'll hear me call it both things. And it looks complicated. It's really not too bad. So first thing we'll do down here for 1 and 2, let's find the point where it would be, and then we'll find the absolute value. So 3 plus 5i, we can graph as 3 comma 5. It would be right there. And if I want to draw in the absolute value, let's calculate that. R is going to equal square root of 3 squared plus 5 squared, which is 9 plus 25, which would be root 34. So we plotted right there. The point itself is the plot. You don't need to draw in the hypotenuse or the absolute value, but the value, the distance away is root 34. All right, negative 6 minus I. Oh, messed that up. All right, so this would be negative 6 comma negative 1. So negative 6, negative 1, and then r would equal square root negative 6 squared plus negative 1 squared. 36 plus 1 is 37, root 37. All right, now we're going to write in trig form. So I need to find r and theta, number 3 down here. R is going to equal, we can rewrite this as negative 3 comma 4. I think we can see what r is going to come out to be. Again, that's going to be a 3, 4, 5. So this will be root negative 3 squared plus 4 squared. So square root of 9 plus 16 is 25. Root 25, which is going to equal 5 for the r value. Theta is going to equal inverse tangent of 4 over negative 3. We want to be in degree mode here. So let me calculate. Let's see, degree mode, inverse tangent 4 over negative 3. I'm getting negative 53 degrees, 53.1. And let's plot this. So negative 3, 4 is going to be up in quadrant 2. I'm going to draw a really bad hypotenuse. I need to insert a 53.1 degree reference angle, and then I want to do 180 minus 53.1, which gives me a theta of 126.9 degrees. Okay, so I need that info. So my final answer, negative 3 plus 4i, written in trig form, is going to be r, which was 5, times cis of 126.9 degrees. There is my trig form. All right, so you guys can try 4. Just note that this would be negative root 2 comma negative root 2. You could find r and theta. Same process. I would sketch that. That's going to be in quadrant 3 because it's negative comma negative. I do want to jump over to number 5 here. This only has a real part, so it's really negative 2 plus 0i. And this is one of the problems where we can work smarter, not harder. That translates to negative 2, 0. I'm going to sketch that. Okay, that's where the point is. I need to calculate r, which you can do with the formula. But remember, r is going to be the distance away from the origin. And that is absolutely 2 units away from the origin, straight left. So I know r is 2. Theta, don't think too hard. Remember, this is 0, 90, 180, right? So that angle is 180 degrees, straight to the left. So 2 times cis. Oh, you know what? We want this in radians, so that would be pi. 2 times cis of pi. 3 plus 3i. I'm going to let you guys try that one as well, and check the key online to check your work. All right. Thanks, guys.